My name is Mike Nakhimovich. I'm an Android developer at the New York Times. And what I'm going to be doing now is a follow-up talk to the wonderful introduction that Dan just gave to dependency injection. So my talk is going to have a little, so first, is anyone in the room who was not at Dan's talk that also does not know what Dagger is? All right, great. So I'm just going to fly through a little introduction that'll show you some of the stuff that he showed, and then we'll move into basically a three-part talk of how we use Dagger 2 specifically at the New York Times. And I think I'm going to be able to answer some of the questions that came up in the last talk of how to actually architect and structure a fairly large code base to work with Dagger. So first, a little intro. What is Dagger? So like many of you know, Dagger gives you an alternative way to instantiate and manage your objects. So rather than you instantiating them inside of your classes, Dagger gives you a location within modules for you to be able to instantiate. And a little history lesson, Juice, a library developed at Google, was a dependency injection library, which I kind of consider Dagger 0. It was made for back-end development. It had heavy reflection, which was very slow on Android. So the fine folks at Square released Dagger 1 a few years ago, which was able to take away a lot of the reflective, a lot of the expensive calls that Juice was making and give us a dependency injection library that was specific to Android. And this was great for most cases. It did have a few problems, like pro-guarding was a little bit difficult since there was some reflection. And it wasn't even though it was one of the fastest dependency injection libraries we had, because there was some reflection, it still wasn't as fast as it needed to be. So that's where we are now. Dagger 2, it was open sourced again by Google, and it is basically the continuation of what Dagger 1 was with some speed improvements. Well, why do we need it? Why do we need to do dependency injection, dependency inversion, or any of this really? Well, to me, good code is testable code. By that I mean it's not code that has tests, but it's at the very least code that you can write tests for. And the reason that you want to write tests is to have less developer anxiety. So I started the Times about a year ago, and I was really happy that we had about 1,000 unit tests at that point, which made it dramatically easier for me to commit new code without breaking something in production. Similar, now that we have interns starting for the summer, they also are going to be able to benefit from us having more tests. And for us to have tests, what we need to do is structure our code base in a manner where it is testable. Not all code is testable, only code that is organized in a manner can be tested. So let's look at something that looked like my code in the beginning. I started Java in high school, and this looked like a simple class that I would have made. So I made a class. This class had a single dependency. That dependency was a model. And I said, well, why not in the constructor instantiate this model? The problem with doing it this way is we have a single method which we're expecting someone to call, our getName method. And what we can't do is test reliably whether getName was called. So luckily, the internet exists. I spent a lot of time on Reddit. I spent a lot of time on the Android subreddit. And the internet told me that, well, I need to externalize my dependencies. What I mean by externalizing dependencies is to my constructor, I should be passing in that model object rather than instantiating it within this class. Basically, you shouldn't really have new keywords within any of your objects. Pass in your dependencies, which will allow you to write tests like the one I have on the bottom here, where you can create a mock model object, record what behavior should happen when someone calls getName. You can then make an instance of your class and validate whether, with that particular model, getName delegated and returned the proper value that we wanted to see. So this is really simple. Again, this isn't really Dagger. This is just externalizing your dependencies to make it easier for you to pass in one dependency during your regular source and another dependency during your test when you're actually running them. The next question, I'm gonna have a little Q&A with myself this whole talk. So the next question is, well, where's model gonna come from? And this is where dependency injection and Dagger specifically is gonna come to your rescue. So what Dagger lets you do is externalize these object creations. And we externalize them by making something that looks like a factory method. It's simply a method that creates an object and returns it. And the only thing that is Dagger specific here is that we will annotate this method with provides. We'll take this provides method and actually stick it into a module. Think of a module as just a container for a bunch of these provides methods. So normally, yeah, you would have one to many of these provides methods within a module. Once we have our module, and this is the first thing that we're getting to that is specific to Dagger 2 instead of Dagger 1, Dagger 2 has the concept of a component. And what a component is, what I think about it, and I'm coming from a place where this component to me is something like a manager. So this component both contains all of those dependencies and also that class that everything that wants to use your Dagger dependencies is going to be connecting to. So what we have here is an interface app component, which we write, which we annotate with what modules should be in this component. Think of it as what dependencies should be a part of this component, so that Dagger can, when we compile, run an annotation processor and give us an implementation of this component. And again, I know it's not perfectly correct, but I think of this as just a dependency manager that is just containing all the actual instances that were inside of all of the modules that were a part of this component. So here you're looking at me not making an instance of my interface. I'm making an instance of a generated app component that Dagger was able to generate based on what interface I told it to use. So in Dagger 2 world, this component is what that object graph call was in Dagger 1. So rather than you calling a single class that is an object graph and passing it your modules, you will be instead making components that are going to be generated that you will then hook into from your activities, from your views, from your services, from all of these Android classes that do not have constructors. And once I register by saying, hey, I want this component to satisfy all of the dependencies or inject all of the dependencies for this particular activity in this case, well, we get to have some fun. We can then start annotating fields with @inject. And once we call from this previous slide that component.inject call, Dagger will satisfy all of those dependencies with actual instances. And we can do this in one of two manners. We could either annotate fields for classes that we don't have constructors for, or we can annotate constructors directly, which will then have their arguments passed in from Dagger. So Dagger gives you two ways to basically do this. And that's as far as I really want to go as an intro of how Dagger and dependency injection works. And now let's get to more of the fun stuff of how we're able to do this in a fairly large application. So I'm going to break my talk up into 3 sections. First section is going to be talking about our module and component architecture. And ours is a little robust. We actually have 6 different libraries that we pull into our main application. These libraries have their own Dagger modules. We also have build types and flavors spanning Google and Amazon. So being a newsreader app, we have a huge user base on Kindle. So unfortunately, we need to be able to manage both Google Play services and devices that are running on Amazon. And the last 2 kind of topics that I'll be getting into is scopes, how we're able to have object graphs that are both singletons for our whole application or objects that are scoped just for a particular activity. And finally, I'm going to touch on testing. Some of the problems that people have had upgrading from Dagger 1 to Dagger 2 is how you're going to be overriding some from tests. And we were able to find a just a simple Java pattern to allow us to do that. All right, so code organization. Like I said, our app is broken up into 6 different build variants. We do both Amazon and Google. We do have our debug builds for our developers. We have a beta group that we release to that is a small, almost like a release build. And we also have our release build, which goes out to our millions of users. So how do we manage all of this? What does this look like? The first thing I want to talk about is modules. Where do we keep all the different modules that we're then going to be pulling into the components that our app are going to be using? The first type of module is our app module. So currently, we only have one production app, which is our flagship reader application. But we do have times when we have Hack Week projects where teams want to build, say, a crossword app or some other app that is going to be wanting to use Dagger. So we organize, the first thing that we have is app module. That is a module that is specific to each client's application. We also have library modules. I'm on the framework team, and we build and maintain libraries that each already have their own Dagger module, which allows apps that will be using our libraries to use Dagger, and they should also be able to use those classes without ever including Dagger. Next, we have build type modules. These would be modules specific to debug, beta, and release. And finally, we have flavor modules for Amazon and Google, which is really important since Google and Amazon seem to want to do payments differently. and do messaging, where you're doing push notifications differently. OK, so app module. Now, our app module manages all of the singletons that are for our application. An example of this would be our parser. We provide, and kind of like Dan said in the last talk, we provide a interface of a parser, which is actually an implementation of JSON. We pre-configure that within our app module so that anytime anyone wants a parser within our application, they're going to get the same singleton or the same exact object that will be already pre-configured with all of our type adapters and serializers that we know our code is going to need. Some of these objects are I/O managers. So we have a custom network layer and also a persistence manager. Both of those will depend on this parser and also give us a singleton going to the REST application, whether someone wants to write something from or to disk or go to the network. And finally, the third type of interesting object that we're holding within our app module are configuration objects. So like I said, we had different library projects. These library projects will expose some kind of manager that our client application will be able to hook into. But for example, for our e-commerce library to work, our client application, the one that is actually including these libraries, will need to have an e-commerce config. So at first we were doing something where we first instantiate an instance of our e-com manager, and then to that we set whatever our config is. But we thought we could do a little better than that. We wanted to have some kind of validation that will show that our e-commerce manager, which is coming from our library project, needs to have some provided config that is going into it. So let me show you how we do that. So like I said, we had our app module providing an ecom config, just a simple provide method that return an ecom config. We then have our library modules. Here's one of our library modules, our ecom module, which is living in an actual AAR. Here, we're going to be returning an instance of an ecom builder. This is one of our dependencies for our e-commerce, or for all of our payment stuff. And what's interesting here is that we're going to be providing a config from the client application to the library. Now, we're going to be providing an interface here, and we're doing that so that our reader application can give us an ecom reader config. If we have a crosswords application, it can give us the crosswords ecom config. So as long as there is a module within that same object graph or the same component that has this ecom config, our graph will validate and someone will be able to use this ecom builder, which is great. And to take it one step further, so we have our ecom library, and like I described, we need to be able to support e-commerce for both Amazon and for Google. So we have our Amazon variants that need the Amazon implementation of our e-commerce. We have our Google variants, which will need the Google e-commerce. And how can Dagger help us with this? Well, let's move on to our next concept, which is qualifiers within Dagger. So not only is Dagger able to provide for you an implementation of an interface, you can also type, using a qualifier, those implementations. So what you're looking at here is that I am returning an ecom manager for the rest of my application to use. I'm saying that I'm providing it, I'm saying that it's a singleton, and I'm actually adding a third annotation here, which is a qualifier annotation saying add Google. And what this means is that if someone tries to inject just an ecom manager, it won't satisfy them with this. They're going to have to actually do add inject, add Google to get the particular ecom manager that is coming from this provides method that has that Google annotation. Well, why is this important? Because we also are going to be providing from the same module another ecom manager that is going to have all of the Amazon payments rather than the Google payments that will go into our ecom builder. And so we have this library now, and it's providing two different implementations of our e-commerce object. So now let's actually flow it into our flavor modules. So now back to our main project, our client project. Our client project within source Google and source Amazon will also have something that is called a flavor, what we call a flavor module. So this flavor module will be providing to our application a non-qualified version of an ecom manager. So before, what we were doing from the library is providing a Google or an Amazon ecom manager. We take that dependency and bring it into another provides method within our flavor module, so then from our flavor module, we can provide just an ecom manager that'll be either the Amazon or the Google one. So based on which based on which flavor you're currently choosing within Android Studio, it'll load the particular flavor module, either the Google or the Amazon flavor module, and return from it an implementation of an ecom manager, which will be backed by code that should only go into an Amazon APK or a Google APK. And what this allows us to do by having these flavor modules is pro-guard out the other code. So unfortunately, if we left the Amazon payments code in our Google build, the APK won't actually compile. Same thing with the Amazon APK. So we use ProGuard. So since there will only be an execution path to get our ecom manager for Google within this flavor, the other one can be stripped out with ProGuard without a problem. So it's important to see that our library is actually providing both Amazon and Google implementations of the same object, but due to us having a flavor module, only one will go into one build variant or another. Now, next I want to touch on type modules. So the same way that we have modules for Google and Amazon, we have modules for debug, beta, and release. And I'm not really going to show the module, but just talk about some of the things that this helps us manage. For one thing, logging. We use SLF4J at work, and the reason that we use this is because we want to use the same logging library for our Java projects as we do for our Android projects. So what we do within our type module is return our logger, and we will be returning different implementations of this logger. So in our beta builds, those are the ones that are going out to small beta groups. We want to have the most amount of logging in to make sure that we know what our users are doing. And within our release build, we'll actually be returning a no-op implementation of this logger. So what you should be kind of seeing here is the same way that as our flavor module, our type module can now pick for our build type what version of logging it needs. We do the same thing for payments, where our debug build, which is what our developers use, will use a no-op version of payments, so you don't need to actually enter credit cards to subscribe. And finally, the device ID. We'll use a static device ID for our debug builds so that we'll be able to check the logs on the server and know that these were builds that came from a developer phone, not from a build that's in the wild. So those are our modules. So that's how we split them. We have some modules in libraries, we have some modules that are in flavors, and we have some modules that are in our build types. So they're living in all the different source trees and in external libraries. So next, I want to look at component composition. And a component is that concept that Dagger 2 has that Dagger 1 did not. And by having a component, it allowed Dagger to basically remove any of the reflective calls that you had. Now, first thing we're going to do is make a base component. And if you remember from the slides that Dan had in the last talk, using Dagger 1, you actually put all of those activities and services and classes that you want registering with Dagger within a module, like little constructor or module annotation, while Dagger 2 gives you a class to do this, and they call that class a component. So what we're going to do is make a component, and here we're going to put a base component into our source main, and this base component will have inject methods for registration for only classes that live within our source main, within our main source. And what we're going to do next is within source flavors, so source Amazon and source Google, the same place we have these flavor modules, we're going to make a component that's going to just use Java inheritance and inherit from our base components. So what we do, the reason that we want to do this is because we actually have activities and services that need to be in either the Amazon or the Google build, and here is where we bring those inject methods in. So AD messaging is what we use to do push messaging for Amazon builds, and we need to register it with Dagger, so we'll leave an inject method within our flavor component. And finally, we have our top level component. So this is our application component. It's going to live within the build type within source debug, source beta, or source release. It'll extend from this flavor component, which is extending from the base component. And this is the only component that Dagger will actually be aware of. So when I said the other things were components, they were just base classes, middle tier classes that this was extending from. So this is the first component, and the only component that Dagger is going to see as an application component. And so that's why on this application component, which is going to be living within each build variant or build type, we will be adding all of our modules. So we're going to add that first application module. We're going to add the flavor module, which will be whichever flavor you currently have selected. We'll add the type module. Again, it'll be from whichever build type you had. And we'll also add all of those library modules. And since everything is on the same component, it's going to be on the same object graph, and we should be able to provide stuff from one module to the next. That's how we're able to provide stuff into our ecom module, which is in the library project, from our application module that is actually depending on that library. So like I said, anything that's going to be registering with this component is going to have access to all of the providers for the particular build variant that we are looking for. So that's how we declare our component for Dagger to see. Now let's look at how we can actually register with this component so we can start injecting all of these classes. We made a little helper class at New York Times, which we call a component factory. So there's a little bit of boilerplate to actually create a component. You're going to be calling your generated code that has the same name as your component. You'll also have to be passing into a builder each of the modules that have a constructor that you're trying to pass a context to. And so we've kind of rolled this all into a simple convenience class we call an app component factory. It's also important to note that this component builder, we keep package locals so that we can actually override them from tests. I'll get to that near the end. So then, within our NYT application class, we're able to make an instance of our component factory. We get to build our component and both retain this component within our application class and inject have Dagger inject all the dependencies into our application class. So this is where that app component is actually going to live. Anything that's going to want to use that app component will be able to, from the application context, get a reference to this app component, and then call the inject method. This will be true for anything that will be across any flavor or any build type. So now I want to step into the activity scope. Yeah, and FYI, my wife, who's not an Android developer, made all the GIFs for all of it. So some of them make sense, some of them don't really make any sense. This one got a good laugh, so I'm happy that this one falls in well. Yeah. Anyway, so back to the activity scope. So everything that we've been talking about now has been application scoped. We have objects like our network client, which is an application singleton. We have things like our e-commerce that is going to be application scoped as well. You only have one of them. Well, Dagger lets you set up scopes. Besides just having an application scope like Singleton, we can actually have a scope for our activities. And the way that we do this is with subcomponents. So what we're going to do is make an activity component. Think of this component as, so before we had an application component, right? This application component was one for our whole application. We made an instance of it and retained it in our application class. Well, like you could imagine, we could also make activity components that'll be one per activity. And because it's going to be one per activity, it can both bind to our activity context so we can provide it, and it could also share objects that are going to be activity singletons. I know that's not the right name for it, but that's how I think about it. It'll be singletons that are going to be one per activity that you can share between all of the views, fragments, and presenters that will be under that activity. Now, we'll start first with the component and then go into our modules kind of backwards of how we did the application one. So here we have an activity component. Rather than marking it as a component, we will mark it as a subcomponent. We'll also define what modules is going to be specific just to each activity. So think of this as we're going to be plussing this into our application. We have our application component with all of those provides methods, all of those instances that are for the application. And here we're going to be plussing in more provides methods and more ways to inject members from two other modules. We'll also be creating our own scope annotation. This one is scope activity. Now, this is different than the qualifier annotation we used, and because this one will actually define scope rather than trying to differentiate two different things. And we'll also here register all of our views, activities, and anything else that we want to be using this graph, the graph that can provide stuff that is for a particular activity rather than for the whole application. Finally, we'll add a convenience method to our application component called, you can call this anything you want, what is on the bottom. What is important is that it's going to return an activity component, and you're going to be adding this to your application component interface. So once you add that, you can create, just like we had an application component factory, we'll have an activity component factory, which will get a reference to our application component from our application class, and it'll call that plus activity component method, passing it whatever modules are going to be in here that depend on the activity context. So we can actually instantiate our activity module here, pass it the activity context. So now this module will be able to both inject an activity context and just be activity specific. Similar to how we were able to instantiate our application component, we can instantiate an activity component. I'm doing it here in an onCreate of an activity. And we can call inject, which will then satisfy all of the fields that this activity would have had. And this is the picture that I thought didn't make much sense, but I didn't have the heart to tell her to take it out. So here we have, next I want to go into our activity component modules. So you notice we had our activity component and it had two different modules. It had an activity module and a bundle module. First I'm going to talk about the activity module. It's something that you'll see in most applications. And then I'll talk about our bundle module, which is my favorite part of the New York Times application. So our activity module. We provide here a few different things. We used to use event buses, and we recently, or not recently, but we moved to RxJava. So one of the things that we provide is published subjects, which we actually use as mini buses so that we can listen for changes from one view to another. This is nice when you're actually trying to have 2 or 3 views that may be in different panes and you want them to talk to each other. You can use one of these subjects as a bus. We also built something for accessibility, which we built specifically, was a reactive text resizer. So we have some class you can register with so that when users resize the text, it'll resize all of the views within whatever your view is. This is important. We're a news application that is on a phone, and we have a startling amount of users that can barely read one letter on a phone. So we have to go all different sizes of what things look like. And finally, we have a snack bar util, which is an injectable class that we actually retain an activity in so that we can make snack bars without passing the activity in. So let me go through each of those. So first, we have 2 provides methods that back our font resizing. We'll create a published subject, which think of it just as a listener that you can subscribe to and then propagate values from. We take this published subject, which we typed as our font bus published subject, and we will inject it into the provider for our font resizer so that our font resizer will then be able to use this external object to notify subscribers that a font change event has happened. So first, let's look at our font resizer. Fairly simple. You could inject a font resizer. You can register a view. And when a settings is being pulled to resize something within our app, this view will be one of the ones that gets resized, which is great. That's great for most of our use cases of actually resizing things. But we have another use case where we actually we have certain presenters that want to listen to font change events so that, for example, they can save that event to shared preferences, whatever that font value was. So what we're able to do, and we have a section presenter, where to its constructor, we can inject just that font bus. And then we can subscribe to those font changes and handle them our own way. What's important to see here is that we can actually inject just the font bus into both our font resizer and into other classes. Now, without Dagger, when I used to program before, I would have actually just passed the font resizer to this presenter, and then this presenter can, from the font resizer, get a reference to that listener. And Dagger, keeping everything in modules, has taught me more to decompose my objects and to separate all of the object creation, which lets us do things like this of just injecting the things that we need. Another nice example of something we have in our activity module is we have something called a snack bar util. And here we're able to, so because our activity module is specific to each activity, and like you saw in a few slides ago, we passed a reference of that activity to our module, we'll then be able to inject our activity into other classes. So what we can do is create a snack bar util that has an injectable activity so that from some other area of our code, we can then call make snack bar without passing the activity in every single time. And this is good and bad. This is good because if your presenter is a few levels down, it makes it easier to not have to pass through that activity context everywhere. But this is bad because it makes it much easier to leak your activity context. So because I'm injecting an activity context here, if this snackbar util had listeners going to application scoped classes, this activity instance would leak. So whatever, just a word of warning, if you're going to be injecting an activity somewhere, treat that class that has that injectable activity as a presenter and unbind that view or that activity from that class. And that's the safest way to really work with these injectable activities. Now, the last thing that I want to talk about within our module structure is our bundle module. And this is, like I said, this is my favorite part of our code base. So bundle management, it's hard. I can't remember to write verbs. For one thing, you need to pass it from one activity to the next. Well, that should be enough in my mind, but you also have to do frag args. You have to pass it to each fragment. You need to figure out how to save state. And we were trying to figure out how can we leverage Dagger to solve some of these problems. And we think we reached a solution, and I actually heard a talk earlier that had a different solution, but let me present to you how we do this. So first, we're going to create a bundle service. This bundle service can take two bundles, a safe state and an intent extras bundle. We'll put them into the same, we'll add all of those extras to the same bundle. And from all of our activities, or from our base activity, we can then retain this bundle service. So what this does is allow our bundle service to have both our safe state and our intent values. We can then, in our onSave instance state, just pass them all back so that they all get serialized correctly. But we could also do a few other things. We can bind that bundle service to our bundle module. So what we're doing here is we are injecting our activity into a provides method. From that activity, we're going to cast it to this interface that we have, bundler, which will allow us to get a reference of this bundle service. So now we'll be able to actually inject this bundle service into views and fragments that are below our activity. That would be nice, but we actually took it one step further. Rather than injecting the whole bundle service, we can inject this bundle service into other provides methods and provide from here exact intent values that were passed into our activity. So if you're looking here, this is something that we use to show articles. We, from our bundle service, take one of our intent values and provide it from Dagger. And because we are providing it from Dagger, we can then, into our comment presenter, directly into its constructor, pass as an injectable value that intent extra. And that intent extra, if you do rotation, it'll actually be the saved one, not the one that was being passed in. And this all becomes seamless because now your bundle module is managing all of your intents. Looking at how we used to do this before, well, we had our article activity, then we passed it, the intent value to our article fragment, to our comment view, and finally to our comment presenter. A lot of areas that we could have made a mistake. Rather, because we're all on the same component, we'll inject locally what we need. And the third part of my talk, which I'll have plenty of time for, sweet, will be testing and how we handle testing. And this is something that we scoured the internet for, really had to look at how other people are doing it, and luckily there are a few solutions of how to test with Dagger 2. So like Dan mentioned in the last talk, Dagger 2 lost the ability to override modules. So before, what you were able to do is have a test module, and it would override anything from your application module, and you can then use those overridden methods. Well, we can't quite do that with Dagger 2, but what we can do is start falling back to just Java inheritance and overriding things when we're instantiating them. Oh, sorry, before we get to that, let me show you the simple version of testing. So the simplest version of testing is when you're not actually going to be using Dagger. So you have classes. You have an inbox preference class. In your source, you may be using Dagger to inject the dependencies, but within a test, you can just pass in those dependencies like you did to any other object and verify whether something happens. Dagger is not needed for this, but what you will need to do is pass in all of the dependencies that your objects are going to need. And this is, the majority of our tests are written this way, kind of like true unit testing, where you're mocking all of your dependencies and testing just that single object, what its behavior is. That's pretty good, but there are times when you're going to be testing with Dagger. By that I mean you want to have that real injectable singleton, where you want to inject a clock instance or something else that you don't want to have to mock every method that exists. So to do that, we create a base test case that all of our unit tests will extend. This returns a test component, and it'll also have a getter for getting the application module. So we have this test component. The test component is very similar to our application component. The only difference is that we are going to be having those inject methods for all of our test classes rather than for all of our activities and views and services. And this is because the tests are what's going to be what you're going to be passing to Dagger to register. Finally, we'll just add another module. Just because this is a separate component, we're adding a test module that's going to have test constants and other things that we use within our test. Now let's look at a test. So here we have a WebViewUtil test, and we are injecting two things into it. We want to inject a network status, and we want to inject the object under test, or WebViewUtil. And what we actually want to do is have a mock version of our network status and have the actual WebViewUtil as it would be provided from Dagger. So to do this, we will remember that getApplicationModule method on our base test case. We will override that method. We will make a new instance of our application module. And the same way that you can override methods in, say, a listener or something else that you're implementing, you can override any of those provide methods that were in your module. So for anyone kind of thinking of, should you have provides methods or not? Yes, you should, because then you'll be able to override them. And now that we have this overridden provides method, those two those two members that we have, the network status is actually going to be a Mockito enhanced or a mock network status, while that WebViewUtil will be the singleton that every other class is getting. Let's look at a test, a very simple test, 2 lines. When our mock.isInternetConnected is called, we want to return false, and then we could put our WebViewUtil under test to validate that some subscribe method was not called when it was not supposed to be called. Great. So here we're using both a combination of injecting using Dagger and injecting with Dagger mocks that are coming from this overridden application module implementation. There are a few gotchas, like I said. You have to have provides methods. So you can't override something that you don't have a provides method for. So unfortunately, we actually started, when we started with Dagger 2, we started without testing. So we only had provides methods, like Dan said in the last talk, just for external dependencies. We didn't have the constructor. But then we moved to actually having provides methods for all of our dependencies, so we can override them from a test. And secondly, this has to be a module that you're explicitly passing into Dagger. So if you have modules that have empty constructors, Dagger does not make you declare them when you're declaring your component. But if you're overriding something, you need to declare it, because you're going to be declaring another implementation of this module to be passed into your test component. So that was how we do unit testing that works with both Roboelectric and just base unit testing. And next, I wanted to quickly touch on functional and espresso testing. And this is very similar to how we did unit testing. We create a component with overridden providers. Now, because espresso testing, we're really running end-to-end, these will be mostly no-op of only the global stuff. So all of our analytics get turned off, our AB manager gets turned off, and we also do our mock network and disk layers that we'll be using for our espresso tests. We'll then create a functional test runner, which will use a custom functional test app, but otherwise our tests will run end-to-end. So let's take a look at it. We have an NYT functional test app, which will extend our regular application class. It'll override that component factory, and I see that I had a weird copy and paste with stuff highlighted, but ignore that. And within this component factory, same thing we're going to do. We're going to return a component builder that will have an application module, which will be our implementation of an application module that has some overridden classes rather than the real one that our source was passing in. So that's why that component factory method within our app component factory was package local, so we can override it here and pass in a component, a module which will have mocks. Next, we're going to have we have a custom functional test runner. We extend just the regular Android JUnit runner. And the only thing that we're doing is saying, hey, use our NYT functional test app rather than using the regular NYT application, the regular NYT app. Once we have this, we will register this in Gradle. Apologies, I don't have a slide for this, but there's a single line that you'll add to your Gradle file that will tell it to use your functional test runner rather than the default one. But other than that, our tests are going to run the same way that any other espresso test runs. So this is as small as one of our tests is. We do run with Android JUnit 4, which will actually use our test runners that we registered in our in our build.gradle file, and we'll write an espresso test that'll delegate to some screen that will show us how, which will run just like any normal espresso test. Yep. So that's as far as I thought I was going to have time to get to. So I'll kind of open up the floor for some questions, comments, jokes. Sure. So our activity components are recreated. We don't retain them on configuration change. We'll recreate them. And I wasn't able to get this slide up and running, but just for your knowledge, our activity component gets created and injects our main activity, our largest activity, in 50 milliseconds. So we felt like that was an amount of time that there was no reason to retain it. And that's why we do everything that we need to retain goes through that bundle service and through the bundle module. Oh, sorry, but that part might have been a little confusing. So we have both the Google and Amazon code within our library AAR that we're pulling in. But we are only putting Amazon or Google specific stuff within the particular flavor module within that flavor. So yes, we only have Google code within Google. We only have Amazon code within Amazon. The only reason that we need to strip it out, I mean, we could have had two different dependencies. One library that was our ecom Amazon, one that was ecom Google. But because of how much code they shared, we went with the decision of have that single library and then let the flavor pick only the classes that it's going to need for that particular flavor, and everything else is pro-guarded out. So the base component and that base in-source main only has stuff that is for both flavors, while the flavor components and the flavor modules are pulling in things from libraries that are specific to that flavor. Yeah, so I feel the only advantage I see to using the Amazon or Google one is that autocomplete is going to work within your editor. If you do named and then you're putting in quotes what the name of the qualifier is, you're leaving it up to developers to maybe spell Google or Amazon wrong, where now I actually have a type. I have a class that is a qualifier, which they can start auto-completing and adding to their inject methods. So the activity component was a subcomponent of our application component. So we have, let me try to pull it up. We had a top-level application component, which is that big inheritance tree coming through all the flavors. But our activity component was a subcomponent, which then is getting basically plussed into that application component. So that line you see on that bottom, that plus activity component line, is living within our application component to set up that relationship of this subcomponent being a subcomponent of our one application component that we have. Any other questions? All right, great. Thank you so much. And the obligatory, we are hiring at the end. But yep, come speak to me if you're in New York or want to move to New York. Thank you.